So, first off, today we are doing section 2 from chapter 7, not section 1. It's a typo that I did not catch until just now, so just know when you go to look in your book or something, it's section 2, not section 1. All right? But we are moving on from adding and multiplying and power to power rule, so our power of product and our power of a power rule. We're going to add on 2 more rules today. So we have the quotient of power rules. Okay, and you can see this one kind of described here. So we have 2 to the 7th over 2 to the 4th. So I have 7 2's on top and 4 2's on the bottom being multiplied together. What they're showing you is, with multiplication, this 2 cancels with this 2. This 2 cancels with that one, this one with this one, and this one with this one, and so on and so forth. Okay, so this 2's, they all cancel each other out. All right, leaving us with just 3 of these 2's on top. 2 times 2 times 2, there's nothing left on the bottom, which is 2 to the 3rd. Okay, they show us again, they show the same thing over here. They did it with letters this time. T to the 4th, so we have 4 t's, and then t to the 3rd, 3 t's. These t's are still going to cancel each other out. 1 on the bottom cancels 1 on the top. Okay, because this t over t, it's equal to 1, just like 2 over 2 is equal to 1. So that's why they cancel each other out. They go to 1, and when we multiply something by 1, it doesn't change anything. Okay, so this just leaves us with 1t, like so. So t to the 1st, or just t. Okay, if you guys can see what's actually happening here, our quotient of power rule says if I take common bases and I'm dividing them, my common base is 2, I'm dividing, I subtract the exponents. 7 minus 4 is 3. Okay, that's how that works. Same here. T to the 4th over t to the 3rd is t to the 4 minus 1, 4 minus 3, which is equal to t to the 1, or just t, like we got there. Okay, so let's look at example 1 here. It says 8, or that's a g. G to the 3rd times h to the 5th over g times h to the 2nd. Break them apart. Okay, I'm going to put g to the 3rd over g, and I'm going to kind of group them. Common bases, common bases. H to the 5th over h to the 2nd. Okay, my quotient of powers rule says g will become g to the 3 minus, remember, when it has no exponent, it has an exponent of 1. Okay, and then h will become h top minus bottom, always top minus bottom, equals g to the 2nd, h to the 3rd. And that would be our answer. All right, so go ahead and pause real quick and try 1A and 1B. All right, so for the first one, I broke 1a up into x cubed over x squared times y to the 4th over y, which becomes x to the 3 minus 2, which is just x, or x to the 1st, and then y to the 4 minus 1, which is y to the 3rd. Okay? Here, I broke it up, k to the 7th over k to the 5th, m to the 10th over m to the 3rd, and then p over p. P over p right away, that's something over itself. That goes to 1 instantly. Okay? That leaves us with k to the 7 minus 5 is 2, and m to the 10 minus 3 is 7. We don't have to bring down this multiply by 1, because multiplying by 1 doesn't change anything. Okay? It doesn't do anything. It doesn't matter. So basically, the p's in this equation, or this expression, they're irrelevant. They don't matter. Okay? All right, let's look now at our power of quotient rules. Okay, so this is like kind of dealing with fractions a little bit. So what you have is 3 to the 4th, or 3/4 raised to the 3rd power. And how this works is you take the fraction and you multiply it 3 times. So basically you're taking 3 times itself and 4 times itself 3 times. Okay, or 3 cubed and 4 cubed. Okay, so basically what our power of quotient rule says is when you have an exponent, a fraction, when you have a fraction raised to an exponent, both top and bottom get the exponent. So if I have 1 over 2 squared, it becomes 1 squared over 2 squared, or 1 to the second is 1, 2 to the second is 4. Okay? So let's look here at my power of quotient. We're going to apply it. So the first thing I need to do is put my 2 on everything inside my parentheses. Okay, so this will become 3 to the second, p to the 3 to the second, over 7 to the second. 3 to the second, 20, 3 to the second is 9. 3 times 2 is 6, over 7 to the second is going to be 49. Okay, you need to see if you can simplify that. So does 9 over 49 simplify? Because basically this is saying 9 over 49 p to the 6th. Okay, so you need to check to see if your fraction will simplify. It doesn't. 9 over 49 is as simplified as it'll go, but you do always need to check, because if it wasn't, say it was 7 over 49, you would have to simplify that, okay? All right, so try 2a through 2d and then check back in. Okay, so for 2a, it became 3 to the 3rd times x to the 4 times 3 over 4 to the 3rd. 3 to the 3rd is 27. 4 to the 3rd is 64. That does not reduce, so your final answer is 27 over 64, x to the 12th. Okay, same here. 5 squared times x to the 5 times 2, y to the 2nd over 6 to the 2nd. Everything got the 2. 25 over 36 does not simplify, so you get 25 over 36 times x to the 10th, y squared. Okay, for 2c, the 9 and the 4 also won't simplify, but you get 2 to the 2nd times y to the 2nd times 2 over 3 to the 2nd times z to the 3 times 2. So you should get 4y to the 4th over 9z to the 6th. And your last one, 4 to the 3rd, this here will become 4 to the 3rd, x to the 3 times 3, over 5 to the 3rd times y to the 4 times 3. So you'll get 64 over 125, and you'll get 64 x to the 9th, and 125 y to the 12th, okay? Right, so if you look at example 3, it says our 0 exponent. So our 0 exponent has a special rule. Anything raised to 0 is 1. Always. So, and to explain this, I'm going to go back to our first one where we had the p over p in our first example here. If I did that, using the method they said, right? We know p over p is 1. We know that. Also, we know that this is p to the first over p to the first. And we can subtract our exponents. So p, 1 minus 1. 1 minus 1 is 0. So that's how we get from there to there, okay? Anything raised to the 0 power is like saying anything over itself is 1, okay? So let's look at 3a here. We have b to the 4th, c squared, d to the 0, b squared over c, and then c. So I'm going to break this up. B to the 4th over b to the 2nd times c to the 2nd over c times d to the 0. All right. This will become, our quotient of power rule says you subtract 4 minus 2, c 2 minus 1, and then our 0 exponent says that this is just 1. Okay, so it becomes b to the 4 minus 2 is 2, and c to the 1, or just c, and we don't need to write the times 1, so that would be our final answer. All right, so go ahead and pause and try 3b. All right, that one shouldn't have taken you very long. The second you looked out here and saw that everything was being raised to the 0 power, man, I didn't care what was in here. It's all being raised to the 0 power, which means your answer is 1. And that's it. Okay? And then our last thing we need to talk about are negative exponents. So a negative exponent, basically the best way to describe this means it's in the wrong spot. So it's on the wrong side of a fraction bar. Okay, so if I have something like x to the negative 2nd, okay, 1, there's no fraction bar in this, so everybody gets confused. But you can make this into a fraction by just putting it over 1. Now I have fraction bar. This is the same as saying these are in the wrong spot. It should be 1 over x squared. Okay, so basically it needs flipped. That's what a negative exponent means. So if we look at 1a, or example 4a here, what we need to do is we need to get our exponents all in the correct position. Okay, so I'm going to break this all up. N to the negative 5 over 1, 1 over r to the negative 2, and p to the 4th over 1. So now everything is in fraction form so I can get things where they belong. Okay. To do this, I'm going to flip n to the negative 5th over 1 is going to become 1 over n to the 5th times the r to the 2nd needs to come on top, and then p to the 4th does not need to move. Okay, so now you have to simplify this back down into one big fraction. Okay, so you have 1 multiplied by r to the 2nd multiplied by p to the 4th. Well, the 1 doesn't change anything, so it just becomes r to the 2nd, p to the 4th on top, because those are things on top of fractions. And then the last one, all we have on the bottom of our fraction besides 1 is n to the 5th. So that's how that would simplify down. That's what that would become. All right? See if you can do B and C, and then we're going to come back and check them. Okay, so I took 2 different approaches to these, and either approach is fine. You pick the one that you think works best for you to solve these problems, okay? So in the first approach, I broke everything up into its own fraction. So I pulled the constants out, made them a fraction. And then every letter became its own fraction over or under 1. So r to the negative 3rd became r to the negative 3 over 1. R squared became 1 over r squared since the r squared was on the bottom, if that makes sense, okay? So that's how I did that. And then from there, what I did is I went through and I moved everything to the top or the bottom to make it to make all my exponents positive, okay? And I simplified 5 over negative 20 down to negative 1/4, all right? Then I, from there, got my like bases together. So I had those two of the like base, which on the bottom we have a base r times r raised to an exponent. So I added my exponents. So it became r to the 3 plus 2. That came from yesterday's stuff, or 2 days ago stuff. And then over here I had t to the 4th and t to the 7th. I put them in a fraction together because those were like bases. And then u to the 5th, u is that's the only u there, so it stayed by itself. Then I add negative 1/4 times r to the 5th, 3 plus 2 is 5, times, I kept my like bases and I'm subtracting my exponents because they're being divided, and then my u to the 5th, I just dropped off its fraction underneath it. Okay, I kept going here, the negative 1/4 and the r to the 5th hasn't changed. T to the 4 minus 7 became t to the negative 3. I had negative exponents, so I immediately put it over a fraction, or I put it over 1. And then again, u to the 5th is done. There's nothing else to do with that. Okay, to flip it, I needed to get my t to have a positive exponent, because you have to have positive exponents. So it becomes negative 1/4 r to the 5th times 1 over r to the 5th times 1 over t to the 3rd times u to the 5th. Which now when you simplify this, the only thing you have on top of a fraction is u to the 5th. So that's what I wrote here. Everything else is under a fraction bar, so it became under my fraction bar. 4r to the 5th, t to the 3rd. The other option you have to do is just break them up with their partners as fractions. So I broke up 2/10 as a partnership. I broke up my a's, I put them together. I put my b's together, and I put my c's together in separate fractions. Okay, 2 to the 10th just became 1/5. And then I have fractions with exponents, so I just started subtracting. A to the 2 minus 3, or a to the 2 in its fraction, and it's a negative 3, so it became 2 minus negative 3, which we all know this actually means add. And then we have b to the 3rd over b to the negative 1, so that became b to the 3 minus negative 1, which again became add. And then one more time we had c to the negative 5th over c to the negative 4th. So I wrote that as c to the negative 5th minus negative 4. Again, that becomes addition. Okay? 2 plus 3 is 5, so I have 1/5 a to the 5th, b to the 4th for 3 plus 1, and then negative 5 plus 1 is still left me with a negative 1, so that means in my final answer I had to drop c down to the bottom of that fraction. Okay, so that would be your final answer. All right, your homework is posted on Schoology. You're doing 1 through 17 odd from this section. Okay?